Good evening, Year 11, and welcome to the Design Technology PPE Night Before News for 2025, remembering that this encompasses textiles and product design information, please. The paper is 2 hours long. That is because it is supposed to take you 2 hours to finish it. You are supposed to use that time fully, otherwise it wouldn't be such a long paper. Please try and use your time well. It's not a case of racing to get it done as quickly as possible so you can have a rest. It's about fulfilling the requirements of all of the questions in as much detail as you can. We know the paper is going to start with some nice multiple choice questions, so there's always a reminder at the front of the paper about how to answer them, making sure you're colouring in the lozenges, and if you make a mistake, put a neat cross through it. The front of the paper reminds you what you need. So it's normal writing and drawing instruments. I strongly advise a pencil and a long ruler, as well as a couple of black pens. You might need a calculator, you might need a protractor. If you're going to pick one of those, go for the calculator because you definitely will need that in the exam. Section A is worth 20 marks, so should take you about 20 minutes. Section B is 30 marks, should take you about 30 minutes, and 50 marks for Section C also. There's 100 marks available. You need to push and get as many as you possibly can. So just a reminder, it's 2 hours long. You do need a calculator and a protractor, and the breakdown of the marks is on the front to help you if you need it. Section A starts off with our multiple choice, and we have gone through all of these topics in lessons over the last few weeks. Levers was new to all of you, and there's definitely a question about identifying the type of lever that they give you a picture of, and also the mathematical question of how far a lever would move if point A moves to the left in one direction or the other way round. Where would point B move to? It's a trick question. It's always the same amount of millimeters. One topic where there was a lack of confidence in a lot of you was the physical properties of materials. So I've put the exercise we did in lessons on this slideshow again so that you can try and identify which type of property goes with which description. You were confident with composite materials. I think you're confident with the different types of polymers. There's not a huge amount of detail asked in this particular paper, but you do need to know the difference between thermoforming plastics and thermosetting plastics. The clue is in the name. You can form some plastics if you warm them up. Some plastics you can't reform when they're heated up because they're already set in that shape. We've also had a look at different types of paper and board and practiced a question about foil-lined boards. Here is a summary of that information to help you. I'm confident because we've done it quite a lot, and also you cover it in geography and science, about that you would be able to identify different types of renewable energy. There's two types of natural timber, and you need to know that the hardwoods are more expensive than the softwoods because they take longer to grow. Because they take longer to grow, the structure of them is much denser. Their grain lines are closer together, and they're better at staying strong, being harder wearing, and less likely to rot than the softwoods, apart from balsa wood, which is very soft, spongy and lightweight, but I have never seen a question about balsa wood. The softwoods are much more open, they're quicker to grow, they're softer to work with, and they're softer in terms of durability, and some good examples are larch, pine and spruce. If you remember from some of the preparation we did in class this week, you need to be able to identify properties of materials, but also what you would make out of them. So this is a good resource to help you prepare for that. The very last question in section A is about electronic components, and if you remember, my advice to you was to know at the very least 2 methods of inputting to a circuit, and that could be something as simple as a button or a switch or a motion sensor, but we've got some other examples on the screen here. Outputs is what happens when you press that button or move that mouse, and you might hear a buzzer or a loudspeaker, or a light might come on, or something might move. So you need to have at least 2 inputs and 2 outputs in your mind. If you're not technically minded, the best thing you can do to remember the process in the middle is that a microprocessor would do it. So the clue is in the name. There's some questions here to help you check that you have covered enough information to be successful in section A. Section B is when we start to see the longer questions, including some mathematical questions. Now, I've gone over this in class with you as well, but just a reminder, if you need to spend some time over the weekend, then it is area that crops up in this particular paper, and the area of rectangles, so you don't even need to know circle theory. We've practiced the time questions. As long as you remember how many seconds there are in a minute, you should be all right. We've practiced a tessellation question, which is making sure that shapes nest together really tightly so as not to waste material. And then we've also talked about tolerances. Some of you will be confident with tolerances because you use them a lot in engineering, and for some of you it's not quite such a comfortable topic. Just be careful to read the question carefully. Sometimes questions about tolerances are asking you to calculate about an amount of millimeters that you can go over or under in your cutting. Sometimes though it's a percentage of the total width or the total length of a shape. So make sure that you read those questions carefully. There's some examples later on in this presentation for you to have a go at. We've revised sources and origins of our materials in the last few lessons. For textile students, we revised the different types of fibres. It's useful for product designers to know those as well. And we've said that specifically in the exam, in any exam, textile students need to know about wool, about silk, about the plant fibres, linen and cotton. And you need to know about the properties of those fibres. So what are they like? Are they lustrous? Are they soft? Are they strong? Are they absorbent? And be able to think of some products you would make with one of those fibres. Likewise, excuse me, product designers can answer that sort of question about polymers or about natural timbers. You don't have absolutely free choice, but as long as you have prepared for at least 2 polymers and 2 of the timbers I've shown you, you should be fine. When it comes to buying materials, we talk about stock forms. And in textiles, we might be buying a roll of fabric, a hank of yarn, a ball, a cone of yarn, a reel or thread of thread, or just a yarn. So try and remember those words. Gave you the context that we wouldn't buy a whole sheep if we wanted to make a woolen jumper. We'd get the wool that had already been cleaned and spun into a yarn and dyed a pretty colour before we went to buy the yarn. In the same way that if we were making plastic or using plastic, we wouldn't need to go and mine any oil ourselves and refine it ourselves. We would buy the plastic chips and then we would buy the shape, or we would buy the shape of plastic that we wanted. So we might buy it as a tube, as a rod, as a sheet, as a pellet, as a film, or a powder. If we were going to buy timber, we'd buy it as rough sawn timber or as a planed all round timber. It might be a square section, it might be a board or it might be a plank, it might be a dowel, or it might be a sheet. And we've revised all of that this week. So this is a sample of the sort of question you might see in section B. So you can have a go at that, and the answers are on the following slide. Section B is also the section where you are asked to explain a making process, and this time round it's about how we would apply colour. So it's the sort of question where you are asked to produce notes and sketches, and you will have a choice about the type of colour application that you talk about. So textile students, I suggest you prepare for at least one type of print, whether it's roller printing, block printing, screen printing, or sublimation. I personally think it's easier to talk about block or screen printing. Product designers, my advice is to make sure you've prepped ideas about how would you explain to apply paint to timber. So you'd sand the timber, you'd fill it, you'd then sand it in finer details. Those blocks show increasing fineness of glass paper. The more particles there are, the finer the grade of glass paper. You'd then prime the wood, which stops your paint being absorbed straight into the wood. It creates a little bit of a barrier so that when you finally put your top coat on, it remains smarter for longer. So I suggest you choose painting, product designers. The big question in section B is the one about the environment. The last paper you sat was unusual because it was about different production systems, but in this paper AQA go back to what they normally do and ask about environmental issues and what we can do to help reduce the problems of the environmental issues. In particular, in this question, they're going to ask you about the extraction and sourcing of materials. So essentially how you get the raw material. In order to get enough marks for this 9 marker, I think you're going to need to include all of the materials areas in your ideas. So textiles are farmed, papers and boards and timbers are gathered through deforestation, and then metals and polymers, the sources for those, are mined. And there's more information about that on the following slide. So this is a sneaky preview of the long question that you will see in the PPE, which is a bit of a prize for those of you who've logged on to the night before news. So you're going to be asked to analyse and evaluate the ecological issues that have to be considered when sourcing and extracting raw materials to make products. So whenever we farm cotton or we farm the sheep to make the wool, there is an impact on the environment. Think about what that might be. When materials have to be mined, and you might mine metal or rock, or you might mine oil. Where is it mined from? It might be mined from under the seabed in the case of oil, or it might be mined on land. What problems does that cause for the environment? You might need to gather your materials through deforestation. So if you're making wood products or paper products, deforestation could have been caused by your product. What's the problem of mass deforestation around the world? How could it be reduced? Those are the things you need to talk about. So I suggest you talk about each of the methods of extraction in a paragraph each. You don't have to do them in the order I've suggested. That's the order that we discussed them in textiles. Section C is the section of the paper that should take you the longest because it's 50 marks. So it should take you about 50 minutes. It's the section of the paper that is closest to the process of your NEA. So if anything confuses you, think about what you've done in your NEA and follow through that process. The order of section C usually follows the order of the NEA. So it asks you to think about research, it asks you to think about the customer, about how you would design, how you'd present the designs, and how you might go about organising making in a professional way. It doesn't allow you to choose how you answer like section B does. So you're answering, all of you are answering as design technologists. It doesn't matter whether you've done product design or textiles, you should all be answering in a similar way. So some brief information to help you prep for some of the shorter answers in this section. You need to be certain of the analysis and evaluative terms, which we have learnt, revised, practiced and rehearsed several times since the mocks. You need to consider safety when using hot equipment and tools. That shouldn't be anything too tricky. We always explain and think about why we need to use research from other designers. We do that regularly in preparation for every single paper, and we do it as part of your NEA work, so that should be fairly simple. You need to be able to explain design fixation, which you should be used to in the NEA because it's where you need to explore different avenues and different ideas. And you do need to be fairly confident in orthographic projection and the idea that you can use your front and your side view to help you draw the top view. There is a very simple representation of that, including some construction lines that help in the top corner of this slide. As with most papers, this section begins with product analysis, and it could be a whole plethora of types of product that you're asked to analyse. The most recent one was the rucksack, but previously we've had garden furniture, hoovers, playground equipment and a GPS watch. You have got something a little bit more unusual than any of those things when it comes to the PPE. What you need to make sure you're analysing from is thinking about the user needs and wants. So whatever the product is, you are asked to analyse, which means identify, and evaluate, which means decide whether it's a good or bad thing, features of that product, thinking about what the user needs and wants. That should be common sense. You also need to analyse and evaluate how you could improve those things with innovative features. So how could you kind of modernise with new ideas the products that I show you, or the exam shows you rather. These two words crop up again, and we have revised and rehearsed this in detail since the mocks. Anthropometrics is measurements of people that need to be taken so that when we design a product, we can design it ergonomically, which means it's comfortable. So looking at the products you see on Tuesday morning, what measurements have designers had to take account of to make sure that those products are ergonomically comfortable for the huge variety of people that will use them. Right, here's another chance to look at the orthographic drawing. So this is an orthographic drawing that shows you an isometric view of a random shape in the top corner. It then shows you the front, the side and the top views. In your paper, you're going to be given a drawing with no isometric view, so you don't know what the product looks like in its actuality, and you're given its front view and its side view, and you have to draw the top view. And obviously you won't have a picture of that product to know what it's supposed to look like. This animation is going to help you see how, if you've got the front and the side view, if you extend construction lines upwards, you can then project from the green dotted 45-degree line, you can project sideways to be able to draw the top view. The diagonal line is not provided on your exam paper. So what you need to make sure you do is memorise that the first thing you're going to add to your orthographic drawing is that 45-degree angle construction line. I'm going to stop talking, but I'm just going to show you the order that you will then try and translate your drawing in. So I'm hoping you're seeing a pattern here where the vertical lines, where they intersect with the diagonal line, that's where you know to come across horizontally. Once all those lines are in place, you can darken up the actual edge lines of the top view. I hope that process helped. I know textile students have had the opportunity to practice. I will bring that same practice down when we do the breakfast waffles on Tuesday morning. This question helps you revise tolerance. So we're not doing the whole calculating distance between the circles and things again. That was a question you've seen before. But one example of a style of tolerance question might be this, where you can say that you can have a tolerance of more or less than 0.5 millimetre. So what's the maximum and minimum acceptable diameters of the holes? Well, if the diameter of the hole is 7 millimetres, the largest it can be is 7.5 and the smallest it can be is 6.5. That's simple. Sometimes, as I've said earlier, you're not asked to give an actual figure, you're asked to work out the percentage. So in this example, if each step is 275 millimetres long, you can go less than 0.5% over or under on your measurements, which means you need to start off by working out what 0.5% is. Apologies. You work out what 0.5% of 275 is, and then add that onto 275 for one answer, and take that figure away from 275 from the second. And that's the main topics covered, year 11. I hope this has been a helpful video, and I hope that you have a good night's rest and come in Tuesday morning bright and early, ready to do some wonderful things in your design technology PPE, trying your absolute hardest to improve your mock score by at least 10 marks. So that will mean paying full attention right up until the end of the 2 hours. I shall see you in the morning, Mrs. Smith.